Solve the following equations and show your work. So for each one of these equations, we want to find the value of the variable that makes the statement, the equation statement, true. Now some of these, especially one-step equations, some of you guys might be able to just kind of look at it, and if you know a little bit about adding, subtracting, multiplying, dividing, and can do it in your head, you might be able to find the solution. What we're going to go through on this video, though, is how to show your work as you are solving an equation so that you can do it for not just one-step equations, but for longer equations as well. So I usually like to draw a line down at the equal sign to represent both sides of the equation, to divide the equation into its two parts. And then we take a look and see what is with the x on the same side of the equation as the x, and usually we undo addition and subtraction first. Okay, so we see a subtracting of 7. So to undo that, remember, we're trying to get x all alone here. We're trying to get rid of the numbers that are on the same side of the equation as the x. So we're going to undo the operations that we see. Negative 7 plus 7 is 0. So we have x plus 0, or just x left on the right side. But we have to always do the same thing to both sides of the equation to keep balanced. Right? So if you think about a scale, if you add 7 to one side of the equation, if the scale is going to stay balanced, you're going to have to add 7 to the other side of the scale. So negative 12 plus 7, think about your negative numbers, you're getting closer to 0 by 7 spots. So that would be negative 5. So negative 5 is equal to x, or x equals negative 5 is our solution. If you put in negative 5 in for x here, negative 5 minus 7 is negative 12. All right. Equation number 2. Again, I'm going to draw a line at the equal sign here. I want to get x by itself. I want to undo the operations that are with the x on the same side of the equation as the x. In this case, I don't have any addition or subtraction in that step. What I have is a fraction bar, which is really a division symbol. So it's x divided by 5 equals negative 4. So to undo division, the opposite of dividing is to multiply. So we will multiply both sides by 5. Now remember, when I multiply by 5 in a fraction, what I'm really doing is multiplying the fraction 5 over 1 times x over 5. So when I multiply by 5, I'm multiplying the numerator by 5. 5 times x is 5x. 1 times 5 is 5 on the bottom of the fraction, and 5 divided by 5 is 1. So when I do that, really what I'm doing is I am undoing the division, just like I did in the first problem. I am canceling out the operation, undoing the operation so I can get x by itself. So really I have a 1x there left, but I usually just write x. And on the other side of the equation, negative 4 times 5 is negative 20. So x equals negative 20 is our solution. In other words, if I put negative 20 in for x, negative 20 divided by 5 is negative 4. So that makes the equation true. I'm finding the value of x that makes the equation true. Okay. Number 3. All right, so again, I'm looking at what's on the same side of the equation as the variable. R plus 7 equals 18. This one's probably one you could do in your head. What plus 7 is equal to 18? So again, I'm going to go through my algebraic steps, though, to show my work. I do have addition or subtraction here. I have addition, so I will undo it by dividing both sides. Sorry, I will undo it by subtracting 7 from both sides. 7 minus 7 is 0, so I just have r left, and 18 minus 7 is 11. So 11 minus 7 turns out to be, 11 plus 7. I'm going to struggle a little bit here this morning. All right, 11 plus 7 is equal to 18. All right, negative 6w equals negative 144. So when we have a number next to a variable, remember they are being multiplied together. So this is negative 6 times w equals negative 144. So negative 6 times something equals negative 144. Since that is a multiplication, and again, I don't have any addition subtraction on this one, so I do have multiplication, and to undo multiplication, we will divide. And I use like like to use the fraction bar as the divide sign. So we'll divide both sides by whatever that number is. So negative 6 divided by negative 6 is 1, or just 1w, or w. And negative 144 divided by 6 is going to be, well, you might have to break out the calculator on this one, right? Negative 144, unless you know your multiplication and division facts. And let's see if we can get this. All right, so 144, negative 144 divided by negative 6 equals 24. All right, so W equals positive 24. Remember, a negative divided by a negative is a positive number. Negative 6 times positive 24 would equal negative 144. All right, so those are all one-step equations because it only took one step to solve. The ones below will be two-step equations. So they will take 2 steps to solve. And when we solve with 2 steps, usually we undo any addition or subtraction first and then undo any multiplication or division second. Our goal is to get the variable by itself. So if I take a look at number 5 here, let's take a look at any addition or subtraction that I'm trying to undo first. I see a subtracting of 5, so the opposite will be to add 5. So 7 times some number minus 5 equals 44. Again, you could try to plug some numbers in here and see if you can figure out what that is, but let's start off by undoing the subtraction. And we will add 5 to both sides of the equation, bring down what's left. We have a positive 7x, and then 44 plus 5 is 49. All right, at this point, you might be able to say, you know what the solution is. 7 times what is equal to 49? Remember, this is 7 times x. And if you're not sure, or if you're just showing your work like you are supposed to do, let's undo that multiplication by dividing both sides by 7. That cancels that out to 1x, or just x. Normally we don't write the 1 in front, but that's a 1x, and 49 divided by 7 is also 7. So in other words, we take 7 times 7 is 49, and 49 minus 5 would be 44. So the x value of 7 is what you would plug in for x, substitute in for x, to make that equation true. All right, last one on the page here. Again, let's start off by undoing any addition or subtraction. We have the equation x divided by 8 plus 5 equals 16. So if we work our way backwards to try to get rid of the 5 and get rid of the 8 to get x by itself, first thing we will do is undo any addition or subtraction. So we will subtract 5 from both sides of the equation to cancel out the plus 5. To undo the adding of 5, we will subtract 5. We will bring down what's left. X divided by 8 is equal to 16 minus 5, which is 11. So something divided by 8 is 11. Do you know what that is? You might have the solution already, but let's go through the showing our work undoing steps. So undo any multiplication or division second. So this is a dividing by 8, so the opposite would be to multiply by 8. Remember what we said a few minutes ago up top there. When you multiply that by 8, what you're really doing is multiplying the numerator by 8. So you really have 8 times x over 8. And remember, 8 divided by 8 is 1. So when you do that, what that really does is it cancels out the dividing by 8. You undo the dividing by 8 by multiplying by 8, and you're left with just 1x, or x. And 11 times 8 on the other side of the equation is 88. So x equals 88. In other words, if I put 88 in for x up top here, 88 divided by 8 would be 11, and 11 plus 5 is 16. So that value of x makes this equation true.